Java is everywhere.
The hallway hums with old fluorescent lights, a soft electric whisper in the quiet hours of a California night. In a half-basement at Sun Microsystems, a man in a plaid shirt leans over a terminal as if listening for footsteps in the code. James Gosling is not a mystic, but at this hour, he treats the compiler like an oracle, asking questions in curly braces and waiting for prophecy. Outside his office stands an oak tree, ordinary bark and leaves, yet to the people in this lab, it feels like a witness. The human brain craves patterns, says the psychologists. It injects meaning into accident and calls it destiny. If destiny wears sneakers and drinks stale coffee, it looked a lot like the Green Team in the early 1990s. Sun Microsystems was a place where engineers spoke in the grammar of the future. Scott McNeely walked the corridors like a hockey captain. Bill Joyce stalked spreadsheets of language design, and the badge reader might as well have said admission to Oz. Patrick Norton and Mike Sheridan traded aspirations in sentences that began with "we could," and Gosling, a Canadian with a mountain climber's stubbornness, began building a language that would not crash just because a pointer lost its mind. They called the project Green. They aimed it at a new appliance world that seemed inevitable, a living room full of set-top boxes that would unify television and computing. There is a ghost in every revolution, the ghost of the thing that might have been. The box never quite arrived, but the language did. At first they named the language Oak, after the tree beyond the window, an engineer's small superstition. It had a syntax that felt like sea given a warm coat, and it removed the knives that cut so many hands. No pointer arithmetic, automatic garbage collection, a virtual machine that acted like a careful butler checking every visitor at the door. Your code would not spill into forbidden memory because a verifier would inspect the bytecode like a customs officer with an excellent memory. The sentence that would echo down the next decades was born in those halls. Write once, run anywhere. In a world of platform feuds, that promise sounded like a peace treaty. The first public sign of the storm came in the middle of the 1990s when Sun showed a browser called Hot Java and a mascot called Duke, a wordless triangle of cheer created to sell the idea that software could dance inside a web page. The name Oak had to go, thanks to a trademark owned by a company that made video boards, so the team chose Java after tossing around a dozen other names, a nod to the coffee that fueled the night shift and a wink at brevity. In 1995, Netscape, the young titan of the web, led by Mark Andreessen and Jim Clark, bundled Java into its browser, and the web purred with tiny applets, animated snowflakes, and spinning globes like postcards from the future. For a moment, it felt as if the world would run inside the browser, and the browser would run on Java, and history had resolved itself into a neat loop. Under the hood, the design was a steel trap disguised as a smile. Programs compiled not to native instructions, but to bytecode, a travel-sized instruction set meant for the Java virtual machine. The JVM was a theater with a strict fire marshal. Every method call got a ticket, every class came through a class loader that could be swapped and chained, each object born on a heap that a collector patrolled like a janitor with a perfect schedule. If you have ever spent a night chasing a use after free in C, you know how the mind frays under the fluorescent buzz. Java said, sleep. The collector will wake at the right moment, pause the world for as little as possible, and carry away what no longer belongs. Performance, that skeptical uncle, crossed his arms. Early Java was safe, portable, and slow. Then, the just-in-time compilers arrived, first as cautious guests, then as resident magicians. Sun acquired a small company that had been building advanced virtual machine technology, and the hotspot compiler turned profiles into prophecy. The JVM learned your program the way a good chess player learns an opponent, speculating, inlining, optimizing, and de-optimizing when the world changed. Code paths that had seemed innocent were rewritten mid-flight into something quick and predatory. Later, engineers would tune the memory landscape with new collectors, a generational scheme that treated young objects like mayflies, then the garbage-first collector that tamed huge heaps, and eventually low-pause collectors with names that sounded like experimental aircraft. The machine was no longer just a runtime, it was a living argument for feedback and adaptation. Security, the other guardian at the gate, became the story inside the story. The bytecode verifier checked the stack with a librarian's precision. The sandbox caged the applet. The signer gave code a passport that said, "I am who I claim to be." For a while, the newspapers spoke in equal parts thrill and dread. If programs could run inside a web page, what else might they do? The answer, sadly, was sometimes the wrong thing, and the headlines recorded those frights one by one. Yet in the long run, the comfort of memory safety, the impossibility of stepping into raw addresses with a loaded gun, rewired expectations for a generation of enterprise developers. Enterprise, that word of ambition and anxiety, became Java's cathedral. Sun stamped 3 bright letters on it, J and 2 E's, and the world learned a catechism of servlets, enterprise Java beans, and application servers that strutted like armored elephants. In boardrooms from New York to Frankfurt, the pitch was simple. You can run your bank on this. You can turn an airline reservation into a transaction with all the guarantees of ACID. You can let 1,000 stateless beans bloom behind the glass and load balancers, and you can sleep through Saturday night. Then the cathedral grew heavy. The deployment descriptors multiplied like ivy. Architects began drawing diagrams that looked like medieval maps of the cosmos. One day, a slender book arrived and shook the rafters. Rod Johnson published a critique of the heavy parts and gave developers something light that still felt solid. The Spring framework offered inversion of control, a phrase that sounded like a martial art, and let code declare its dependencies instead of hunting for them. Around the same time, Gavin King's Hibernate taught object relational mapping how to stop being a war crime and instead be a practical treaty. Together they moved the locus of power from the bloated container to the developer's hands. The mood shifted from cathedrals to workshops. On the other side of the planet, in Tokyo and Helsinki and Shenzhen, Java rode in a different carriage. Phones, not yet smart in the modern sense, ran small Java runtimes that powered games and message clients and the first whispers of mobile commerce. Java Micro Edition fit into a memory footprint that would make a modern developer laugh and still manage to be useful. Millions of devices, then tens of millions, then hundreds of millions. The little runtime that could help an entire generation believe that software might fit in your pocket without losing its dignity. In parallel, the language itself learned new tricks without forgetting its manners. With the release that Sun called 1.2, the collections framework under the careful hand of Joshua Bloch taught everyone to prefer interfaces to implementations and algorithms to ad hoc code. Assertions arrived and made defensive programming less of a rumor. Then came the release numbered 5, and the type system grew parametric with generics. Annotations gave metadata a first-class seat, and concurrency utilities written and curated by Doug Lee entered the standard library like a quiet lever that moved mountains. Threads had always been there, of course, but now there were executors and callable tasks and concurrent maps that saved you from writing error-prone locks on a rainy Friday. As the century turned its first corner, the world's biggest companies began to trust Java with their crown jewels. Banks pumped trades through JVMs that sat near the exchange floor and warmed themselves with transactions. Search engines used it to crawl and index the web, then to build the textual cathedrals called Lucene and the servers called Solar and Elasticsearch. A new breed of data systems appeared, Hadoop built by Doug Cutting and friends, clusters of commodity machines performing map and reduce like an assembly line in a fairy tale. And under the hood, Java kept the pieces from tearing each other apart. Twitter moved workloads onto the JVM Cassandra, born at Facebook, spoke Java. The runtime had become Switzerland, neutral, reliable, and surprisingly quick with a knife when performance demanded it. Then came a legal storm that would last a decade. Google launched Android, and developers around the world wrote apps in a Java dialect that compiled to a different bytecode for a different virtual machine. The argument that followed was about API, design, and fair use, but underneath it lived an older question about how software inherits from its ancestors. Oracle had acquired Sun, and with it Java, and now Oracle and Google argued in courtrooms from San Francisco to Washington. The United States Supreme Court eventually called the use fair, and the decision read like an essay about creativity, scaffolding, and the right to learn from the shapes that came before. Meanwhile, billions of devices taught a new generation to think in curly braces and garbage-collected heaps, even when the runtime under the floorboards was not the classic JVM. Oracle's stewardship changed other things too. Sun had opened Java's source under a license that allowed the community to build OpenJDK, and the code moved to a republic of vendors. Red Hat maintained builds, Azure nurtured clever garbage collectors and quiet speed. Amazon stamped its name on a distribution. The Eclipse Foundation adopted the enterprise APIS and renamed them Jakarta. Release trains began to run on a predictable calendar every 6 months, with long-term support releases marked like milestones on a highway. The language added lambdas and streams in a release numbered 8, and suddenly the code felt lighter, more declarative, close to the way a mathematician speaks when the coffee is good and the theorem is almost in reach. Then modules arrived, a surgery that cut and stitched the platform into manageable organs. Records simplified the boilerplate that had made novices scowl. Pattern matching gave the type system new grace. Most recently, virtual threads arrived, and concurrency felt again like a solvable puzzle. The old chant about write once, run anywhere had a younger sibling now. Write clearly and let the platform do the heavy lifting. Culture matters as much as compilers, and Java grew a culture of steely patience. The Java community process, sometimes mocked for its formality, kept the center of gravity broad. Java 1 filled San Francisco hotel lobbies with conversations about class loaders and bytecode instrumentation and the fine art of tuning a garbage collector at 2 in the morning. There were t-shirts that read, "I love threads," and there were hallway debates over whether checked exceptions were a gift or a curse. Psychologists talk about the endowment effect, how people overvalue what they own. In Java land, it led to affectionate wars over the smallest syntactic change. That, oddly, kept the language honest. The JVM also discovered it was a hospitable host. Martin Odersky gave us Scala, a fusion of object orientation and functional programming with types that could make a professor clap and a rookie weep. Rich Hickey built Clojure, a Lisp with a smell of pine trees and an obsession with simplicity. James Strachan and friends released Groovy, scripting ease with static options when you wanted a seatbelt. JetBrains, a company from St. Petersburg that had built a beloved IDE, created Kotlin, and convinced the Android ecosystem that a modern, pragmatic language could keep all the runtime gifts while shedding old ceremony. The virtual machine did not just run Java, it ran a family reunion. Tools grew up alongside. Ant built projects with XML that whistled in the wind. Maven imposed conventions that felt like rules and saved the world from certain kinds of chaos, and Gradle married the two. Continuous integration came with a butler named Hudson, who later changed his name to Jenkins and kept the build green while you slept. NetBeans rode out of Sun with gusto. Eclipse turned IBM's tooling into a giant open project, and IntelliJ became the editor many developers described the way a violinist describes a Stradivarius. In rooms filled with the blue light of monitors, these tools taught people to think in refactorings, to treat code bases like living cities rather than piles of bricks. Security scares never fully died because nothing so widely used can be entirely free of ghosts. Applet sandboxes sprang leaks, enterprises forgot to patch, headlines trembled, and then the community patched and moved forward. The bytecode verifier remained the watchman that never sleeps. Kerberos configurations and JAAS and key stores became the quiet vocabulary of engineers who kept the lights on in banks and airlines and hospitals. The work was less glamorous than an applet bouncing across a web page, but it was the sort of work that lets planes land on time. The years added finesse to performance. Tiered compilation balanced quick startup with deep optimization. Escape analysis learned to stack allocate what once lived on the heap, turning short-lived objects into smoke. Profilers like Flight Recorder and Mission Control gave engineers the instruments of an airliner cockpit. Garbage collectors learned new dances. The pause times that once felt like hiccups became tremors you could scarcely feel. A research project called Graal, grew into a compiler that could replace the old ones and even compile Java ahead of time into native images that started like lightning and sipped memory, useful for a new world of tiny cloud functions and containers that appear and vanish like fireflies. By the time the 21st century reached its second decade, you could trace the language's fingerprints through the global economy. Trading systems whispered in its idioms. Fraud detectors learned customer habits with machine learning frameworks that ran on the JVM search and recommendation engines, message queues with names like Kafka and brokers with names like Artemis, log aggregators and monitoring stacks all sang in the same register. There are other languages that move faster, others that let you sit closer to the metal, others that dance with fewer words, but few that have been trusted with so much, for so long, by so many. Trust is a psychological contract. One bad night can break it. Java earned it the hard way over years that turned into decades. If you want the untold side of the story, listen to what the veterans say in the quiet part of the conference, the conversations that happen when the keynotes are done and the badge scanners are tired. They talk about memory models drafted with the precision of treaty law so that threads would not surprise one another. They mention the names of the people who wrote those papers and shepherded those specifications, how Doug Lee's abstractions made the rest of us feel less alone in the labyrinth of locks and fences, how Bill Pugh and others forced the language to tell the truth about happens before, about the visibility of writes and the ordering of reads. They remember the green threads of the early runtime, then the native threads, and how server rooms fell quiet when a pause time dropped from seconds to whispers. They also talk about the days when Java became a political object. When Sun faded and Oracle took the helm, some feared the ship would turn into a private yacht. Instead, in a mixture of corporate will and community stubbornness, a new balance emerged. OpenJDK became the common ground. Vendors competed on polish and support. The enterprise APIs migrated to the Eclipse Foundation, changed their name, and kept working. There were license debates, there were trade-offs, and there was the slow realization that a platform used by so many is too large to be owned by one mind. All languages carry secrets. C carries the secret that power is dangerous. Python carries the secret that simplicity is a kind of magic if you know when to stop. Java's secret is mercy. Mercy for the programmer who is working at 2 a.m. with a pager by the bed. Mercy for the team that inherits a codebase with 1,000 moving parts and a deadline that eats the calendar. Mercy for the company that needs to deploy the same service in Frankfurt and Mumbai and Palo Alto without dragging a truck of platform engineers to every city. Mercy is not flashy. It does not trend on social media. It keeps the water clean and the lights steady. There is also a secret about time. You can measure a language by its syntax, its speed, its memory footprint, or the size of its standard library. But the real test is the spaces it builds in human minds. Java became the lingua franca of universities that needed a first language that would not betray freshmen on the third assignment. It became the lingua franca of banks that could not afford surprises. It became the lingua franca of teams that span continents and whose members never meet except in a code review window. A language becomes an institution when its patterns settle into muscle memory across the world. One last image for the archivist's reel. A conference center in San Francisco, the air faint with the scent of carpet and coffee. On stage, a speaker demonstrates something small but beautiful, a stream pipeline that turns a messy list into an elegant result in 4 lines. In the back row, an old engineer smiles because the real star of the show is not the line count, it is the continuity. From the oak outside the window to the bytecode in the VM, from applets to microservices, from the first garbage collector to virtual threads, the thread is continuous. The oak did not become a skyscraper, it became a forest. The untold story of Java is not that it conquered the world. That part is obvious and frankly a little boring. The untold story is that it built a civilization that never stops refactoring itself. The compilers get cleverer, the collectors learn new dances, the libraries absorb the hard-earned wisdom of practitioners, the governance grinds forward like a glacier that never melts, and the people who grew up on it teach the next cohort why boring can be beautiful. It is a language that smells like coffee, yes, but it tastes like patience. In an industry that sprints toward every new thing, patience can feel like courage. There is a legend that the name was a joke, a marketing flourish slapped on a serious piece of machinery. Legends are fun, but the archive is kinder. The name fits because the language wakes up the world in small cups again and again. A developer in Nairobi closes a ticket. A bank in Zurich processes 1,000 payments a second and never loses count. A hospital in Sao Paulo checks a lab result and schedules a life-saving treatment. The JVM purrs, the verifier nods. Somewhere, a garbage collector hums through a young generation and finds nothing left to do. If you listen closely, you can still hear the fluorescent buzz of that hallway, the soft clack of keys, the way Gosling exhaled when the first class is loaded and did not crash. Every empire begins with a story whispered in a room that smells of dust and hope. Java's whisper grew into an oath, and the oath became a promise kept. Write once, run anywhere. Write clearly, run forever.